not doing anything. It's telling me that it's recording, so hopefully it's recording, and I'm going to share my screen. And let's see, desktop number 2. Can you guys see desktop number 2? Looks like there's a Chrome browser here. There's some Rhino stuff back in the background, probably. All right. All right, so like I said before, just a second ago, actually, 2.2, Project 2, Week 2, whatever, has been posted. Go ahead and take a look at that. For today, what we're going to do is we're going to discuss taking a surface and breaking it up into structural and skin components. Okay, so we're going to do a lot of review over the stuff that you watched over the weekend, put it to use. We'll throw in a couple more tools. And so I'm going to do the demonstration today in class. I'll record it. I'll get that uploaded and to YouTube and Canvas shortly after class today, just to make sure everybody can rewatch that if you need to follow along and do it on your own. What I'd recommend is that if you want to follow along, that's fine during class today, but don't get lost in the weeds, because you can always rewatch the video. It's not that long, and frankly, you can always skip and jump. But it's really important that I sort of it's really important to me that you sort of understand less about the specifics of each little widget I pull down and plug in, and more about conceptually what's happening. That's the important part. Learning where all the little tools are and ins and outs of Grasshopper is you know, that comes with practice. So anyway, we'll go ahead and do some stuff in Grasshopper, and then I'll also show you a Rhino script file that you'll probably use in order to automate part of this process in preparation for laser cutting soon. Okay, so again, that's under 2.2, right? So Project 2, Week 2, basically. If I go back to the introduction for the, oh, wrong one. Sorry, if I go back to just the original project brief, there's a schedule in short here. And so we're talking about grid shell ribs today. Again, Wednesday, Kyle Keithis will be here to talk to us about the workflow to get the laser cutter. You'll have some stuff to do, obviously, to prepare to start laser cutting. And so don't worry, then we'll assume that by Monday of next week, you might actually you might be ready. At least some of you hopefully will be ready to start setting up for laser cutter times and things like that. But then we'll start to nail it, sort of dial into some of the skin components, the shade components that sit on top of the structure that you're going to laser cut. And so we'll talk about that, as well as how to sort of model their performance and use that performance model to then begin to sort of tweak the design so that the shade components perform based on a certain criteria that we set up. Right, so all very exciting, but we'll be starting to do things in parallel, right? So it's not like you know, you can laser cut during course class time. And so we'll be using class time to sort of work on things while you're sort of in the queue waiting to laser cut. You know, you can always be doing these sorts of things. Preparing the drawings, preparing the diagrams. We'll have a really nice exploded axon that sort of shows all the pieces and how they sort of go together. It's like, think about an IKEA instruction manual on steroids, all in just one beautiful articulated drawing. So like a Popular Mechanics diagram of a car engine or something, right? Or a transmission, where all these little pieces are like sort of exploded out and you sort of see how things work. All right, so that's where we're going. Ta-da! The example files that you need are right here. So there's a Grasshopper file that we'll talk about. Well, I'll be sort of giving you 2 options for the surface that you use that you begin to make a grid shell out of. And then also the Rhino script file here, you can download it and then you can run it on your own system at home. Okay. So without any further ado, this first file called shell surface classifications.gh, I already have that up here. Let me just pull it up. All right, and what that does is it basically, I think I showed this to you the other day, but all that really is it's me creating a weird wavy sine wave surface, right? All I do is really, I just sort of, I make 3 functions here. Of course, all I'm really doing is making a grid in X and Y, and then for the Z coordinate, to make a grid of points, I'm plugging in values into a cosine plus sine function or expression. The expression gets solved, gives me a bunch of z coordinates I can plug in, right? And so that grid of points basically is pretty typical. If you look at a top view, it's just a grid of points in x, y. But in the z, it sort of goes up and down in these sort of sine and cosine patterns, right? So then I take that grid of points and I create a surface from the grid of points. And then after that, really quickly, if you think about this, what I'm doing is I'm just sampling two specific portions of this surface, right, down here. And those are the two different surfaces that you have at your disposal. You can pick from one of those, right, one or the other, to use for your grid shell, right? So we're basically what we're doing is we're looking at surfaces, and we're sort of saying if you define a sort of surface geometry, right? Let's say for the envelope of a building, then it's all about taking that and then breaking it down into componentry, right? To sort of look at structure and skin and those sorts of things, right? With the shell, there's a specific structure that we'll be dealing with, and I'll show you the demonstration here in a minute of that. But essentially, what you each have to do, I'll just go ahead and turn off all this other stuff here. Turn that preview off. Turn off the preview of these points. Is you need to decide, do you want the sort of dome shape, or do you want the saddle shape? And you can bake one or the other into your Rhino file, and that's the surface that you're going to use, okay? And I anticipate roughly half of you will pick one versus half of you will pick the other. We'll see, yeah. But this is specific to, sorry, I want you to start with these because they're specifically sized to fit all the components, so that no component that you make will fall outside of the laser cutter bed area. Okay, first and foremost. Second, each presents its own challenge, right? One, we have a completely, the concave geometry in both directions is pointing the same way, right? So it starts to become a dome, a doubly curved dome-like surface, right? Sort of a bowl right here. Whereas we have the second one is more of a saddle geometry. It's still doubly curved, but the curvature goes in the opposite direction, let's say latitude versus longitude, right? So U versus V. All right, so I've already baked both of those into my Rhino file just so you can see them, okay? And again, just as a friendly reminder, to pull Grasshopper back up, right? So all you have to do is select one of these widgets. You don't even have to select it. You right click on one of these widgets, you can hit bake, and you can select which layer to bake it into. And you get that version, that static version of that surface patch out into Rhino as a surface now. So the way I do that is, I take this larger surface, and then I basically construct a two-dimensional domain, and I sample by iso trimming the surface. I sample just a portion of the surface. And that's something that you guys looked at over the weekend in the videos I posted and you were supposed to watch, right? If you think about this for just a moment, what we do basically is we, here, let me just pull this up. And let me just turn this off. There we go. All right, let me just turn on my annotate tools. It'll be a little easier to draw over this, I think. And so what I do is I give it a set of coordinates, right? And essentially, if you think about, like, if you guys ever, looked at the Jeffersonian grid, looked at Google Earth, right? The Earth, regardless of, its shape, its actual geometry of terrain, right? We've superimposed a grid on it in a lot of different places, right? As you know, anytime you look at, let's say, Las Vegas Valley in Google Maps, right? And so if you think about sort of giving it a latitude, set of latitude lines and a set of longitude lines, and then looking at this sort of land parcel boundary, right? Let's say this is Tropicana, this is Flamingo, this is Maryland, and this is Paradise or whatever, right? We get campus, essentially, right? So that's all I'm doing here is sort of defining a U coordinate, two U coordinates and two V coordinates in order to just sort of define, right, that plot of land, that parcel, and the larger sort of surface here. So that's all I'm doing here. And so I do it here and I do it here. And that gives me two different surfaces. Let me just turn off my annotate tools really quickly now. Let's see here, right? So there's this surface, right? Goes from u of 0.25 to u of 0.5, and then from a v 0.3 to 0.7. Okay. Of course, I could always change that, right, by changing these. I don't want to do that, but you get the idea. Okay. All right. So you have this Grasshopper file. You'll have to open it up, and then again, you'll have to sort of make a decision. Do I want this sort of surface, or do I want the sort of saddle-shaped surface? Right. Both are doubly curved, and both have their own challenges. Right? That's your choice. All right. So anyway, I've baked both of them in for today. Okay, just so you can see both of them, and I'm actually gonna move them apart just so they don't interfere too much with each other here. Open up Grasshopper, and then I'm going to show you what we're going to do as a demonstration today in class. Okay, go ahead and turn this off. But you'll take this, and what we're going to do is we are going to generate U curves and V curves, right? So iso curves. So we'll find the wireframe of the surface basically. And we'll tell how many times to divide the surface in U and in V in order to create those iso curves. Then we'll also offset the surface and create a second set of iso curves. And then what we'll do is we'll make a surface between both set of iso curves in order to create this sort of two-way rib system. Okay. All right. So I'll just build this really quickly. Oh, no. Sorry. Let me just turn the previews off. We'll go through this widget by widget, and then I'll build it in situ. Okay, I always like to sort of look at it and say, okay, here's what it's really doing, right? Let's talk it through, and then we'll build it, right? Okay, so I've taken the surface that I baked into Rhino, I've referenced it back into Grasshopper using the params surface widget, right? Where I right-click and say set one surface, and then it allows me to select that surface in Rhino that I baked in earlier from the surface classifications file. Okay.
Hey, Josh, I have a question really quick.
Sure.
So I know that we're using the ISO trim widget to take a section of the surface that we made.
Yeah.
If we had the original surface, because it seems like we're either just pulling like a sine or a cosine wave out of it. So if we had the original where it had like multiple waves to it, would that be too and we re-parameterize that surface? Would that be too complex to add? You know, like that parametric design that we're doing, or like why are we iso trimming to like get like a simple curve out of like something more complex is my question.
Oh, you
Does that
mean
make sense?
picking up just a part of that surface?
Yeah.
Oh, right. Yeah. Well, there's two reasons. First of all, I made that surface and I didn't really even dial in like the bounds of it. And so, for instance, let me just open that back up for you. Shell surface classifications, I believe, right? So what we're doing essentially when we're solving for X, Y, and Z coordinates, right, is we're plugging in, let's see, something from, okay, so for the Z, essentially what we're doing is we're saying, okay, take the X parameter, takes the X input and the Y input, plug them into cosine and sine functions and then add them, right? And so what that basically does, and then what I'm giving it over here is a range, right? So 0 to 4 pi and 0 to 4 pi.
Mm-hmm.
And so what I do is I just get this really large unwieldy surface that just keeps going. And all I'd have to do essentially is increase the granularity here and then increase the range. Like let's say instead of 4 pi, 12 pi or 19 pi or times pi or whatever it is, right? But that doesn't break things down into very, very specific dimensions that I need in order to make things fit in the laser cutter. And I don't want to make something.
Re-parameterize that?
I didn't re-parameterize it. I'm just trimming it. I'm just saying, just pick this version or this part of it. See the green over here?
Yeah, but so my question is are we like instead of picking that simple like portion of the surface, if you were to do it at the same scale, would you still, do you think you'd still be able to make that same, like the parametric design across that whole entire surface rather than that just one trim of that surface?
Yeah, probably. But there's a scale issue here, right? So to me, you know, the question is, what can you do an 1/8" chipboard, or sorry, not 1/8", but 1-ply chipboard. So 16th" basically, 16th" chipboard, 060. And with the scale that we're working at, with the constraint to the laser cutting bed size. So if, for instance, if you scaled this entire surface down, then, you know, you could do that, but then you have a sort of scale issue where the ribs actually honestly look too thick compared to how few of them that you actually have going across. So for instance, if I scaled this down so that this was minimum 16 inches in the longest direction, right? Then what happens, like, so that would easily fit an 18 by 32 inch or whatever it is, laser cutter bed. Then what you're going to end up with is something that's either, it's going to be too thick for the spacing, right? It's just going to look really odd. Trust me on this. Because I did a lot of study on this before I sort of narrowed it down. I just wanted to make this, I wanted to make it sure that each of you get something out that you'll be really proud of. And honestly, all of these look different because of the way that you, first of all, you have to choose like the spacing and density of the ribs. But then you also create your own unique shading component on top that gets, you know, deployed on each cell. So the reason why is simply to make sure that this will work out with the scale issue of the material and then the tool that we're using, the laser cutter. So again, it's just basically following the constraints of production at this point. Okay, that's why I did it. Does that help a little bit? Yeah.
Yeah, definitely. Thank you.
Great question. But yeah, I mean, certainly, you know, it's just a size issue scaling up here. You know, what would be really interesting is to, you know, to do this, but, you know, finding a different material that, you know, you could laser cut thinner. But honestly, I don't want everybody working at a scale where you have to like get the magnifying glasses on and you know, start to really worry about the chipboard, for instance. It's going to have to curve in a direction as well as slot and tab. And so with those slots, those are the weak parts. And so what happens is these things actually start to break down. And so there's also a sort of thinness or thickness there's a thickness you have to achieve to the material in order to prevent it from just sort of automatically failing, which I've also encountered. So if you know, in other words, if this got a lot denser, then we'd also have to go with a lot less structural depth. And then, you know, chipboard it'll start to rip and tear on you. So there's a whole, it basically breaks down to the sort of material reality of the material. Sorry, the physical reality of the material and then the tools that we're using. Yeah. Sorry, having a hard time talking today, but hey, there we go. All right, so back to this for just a minute. All right, so we take this surface, and really what I'm doing is I'm just sort of making, here's where we plug it in, right? We plug it into this widget that basically wants a UV coordinate. And then what it does is you see the icon here? This is a surface, this orange thing. And then there's a little UV point. And then what it does is it gives you the longitude and the latitude through that point, right? So in other words, it gives you an isocurve, vertical isocurve and a horizontal isocurve, okay? A U and a V, right? And so that would be easy enough to make a multi-dimensional slider and give it a UV parameter, right? Like let's say 0.5 and 0.5, and that would be a sort of a midpoint somewhere in the center of that surface, right? That's what we know. And in fact, I could do that here just to show you, right? Let's go to the surface tools. And, oh, sorry, the curve tools, because we're making a curve. And go to the spline, I can go to isocurve, right? That's the thing we're using here. I can go to plug the surface in. I'm gonna go right click and say Re-Parameterize so that the limits of U and V go from 0 to 1 and 0 to 1. And then I can plug in a multi-dimensional slider from the params tab. Oop. plug that in. You can see, yeah. So not only does it give us that point, but what it does is it draws the U and the V iso curves through that point for us, right? Pretty sweet, huh? So if I can do that with one UV coordinate, what I actually want to do is I want to give it a list of UV coordinates so that I get a list of U's and a list of V's. And those will become the shapes for my ribs, right? My structural two-way shell, grid shell ribs, right? So let's try that. I'm just going to go ahead and delete this. I don't need one UV parameter. But essentially what I want to do, since I'm going to re-parameterize the surface, go from 0 to 1, is what I've done is I've used the range tool. You might remember this from the very beginning when we were talking about making ordered lists of numbers, right? And we talked about serial, and we talked about, we talked about series, and we talked about range, right? So if you go to the Sets tab and go to Sequence, there's a number of different ways you can create an ordered list of numbers, right? So series would be, again, we give it the first number, we give it the step size for each successive number, and then we tell it how many values of, how many numbers we want in the list, right? So we start at 0, step by 1 each time, 10 times, and we get 0, 1, 2, 3, 4, 5, all the way to 9, right? Range is a little different in that what you do in order to generate the list of numbers is you give it a domain like 0 to 1. You tell it how many times to divide between that range, how many steps in between. And so, for instance, if we go from 0 to 1 and we say divide it 10 times, number of steps, then we get 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, all the way to 1, 0.0. Right? And so that would be a really great way, actually, to begin to generate a set of UV coordinates, right? And that's what I'm doing. I'm taking a domain and I'm dividing it a certain number of times, in this case 23, because I have a number slider, right? And so I divide it that many times, and look, it gives me a number of values between 0 all the way to 1, right? And so we're going to generate both U address a parameter and a V parameter, right? We'll cross-reference those together. Actually, I don't even want to cross-reference them. I'll just plug them in. In this case, I just need to plug them in as an X and a Y so that I get them together, and then I can plug them as a UV. Okay. So what I'll do is I'll turn those on. You can see now, essentially, what I'm doing, let's see here. Let's do the chat. So are we using only one of your examples of the project? Yes. You'll be using, yeah, sorry. So with that, the Grasshopper file I'm giving you, that surface classifications, you're picking one of those two files, one of those two surfaces in order to use for your project 2 surface, okay? And that's, so it'll be the perfect size so that you won't have any issues with laser cutting and all that stuff, all right? Yeah, good question, Ali. Sorry, I just got your question in the chat. All right, so back to here, annotate. Here we are, la, la, la. All right, so, oops, I can't move anything around now. But basically what I'm doing is I'm generating a list of numbers, right? And then I'm plugging them into a point widget just so at the end I get like the first number, comma, the second number, and I can plug them in as UV coordinates, okay? What this does is it gives me a 0, 0, and then a 0.13, 0.13, and then a 0.27, 0.27, all the way across. It gives me points that move across diagonally across the surface, all the way to this point. And then I plug it into this widget. What it does is it gives me the U's through each of those points, and then also the V's through each of those points, okay? It separates them out in their own list. So here are the U's and here's the V's, okay? Right. Then in parallel, I take this original surface and I offset it a certain amount, right? Which I can control with a number slider. And I also map its isoparameter curves. Just turn the preview off here. Right, and so by the end, you can see I get a set of U's and I get a set of V's, right, from each surface. And then last, what I do is I just create a surface from 2, 3, or 4 edges, right? And so I plug in the U's from both the original surface and the offset surface, right? And so what it does is it takes the first U curve and matches it up with the first U curve in this data tree, and then makes a surface from it, right? And it does that 24 times in this case because we divided things that many times. Okay. And we do the same thing over here, right? So we get rib system going in two different directions, like a grid shell. We can adjust the structural depth of the structural ribs, right? And we can adjust the density, like the spacing and the number, both in the U and the V direction. Okay. All right. So that's kind of a lot to take in, but, oh, by the way, data trees, right? Data trees, yeah, data trees, right? So what's nice about this is that once we plug in a surface, then we get a number of U's out and a number of V's out. It's because we plugged in a list of UV coordinates. So for each UV coordinate that we plugged in, then it made a separate branch for the output on a data tree for us, right? What's nice is that if this was just one big list instead of a data tree, right? Each object is on its own branch in a data tree, right? Each output. And so what happens is it takes the first branch from here and the first branch from here and matches those up and makes the surface and puts it in its own first branch in this data tree out when we make the surface. If these were all just one big dumb flattened list, then what it would do is it would take all of these in order and try to match them all up with each other and the same with the other one, right? So this is where data trees become really useful in organizing our information, in that we're trying to plug in multiple sources. And some of these widgets just literally want, let's say, the first curve versus the second curve in order to make a surface. If you plug these in as just a generic list, then it's not going to work out so well. So this is a nice place where, this is a nice situation where the data trees actually help us. And we'll talk more about data trees as we go. What you'll find is that the organization of the data and understanding what we're plugging in and making sure that things are congruent when we plug two inputs in at the same time becomes really crucial and critical for the computer to make sense of things and to do exactly what we tell it to do, right? So, but as we start to build in complexity, where we start to add in like lists of things, you know, that economy of scale again, data trees are an inevitable sort of way to sort of organize things so that the more and more complex we get, the better tools we have to sort of keep things organized, right? So hopefully that'll start to make more sense as we go. I think it will. Usually does. Sometimes it takes a little while to click. So if you're going like, wait, what? What the hell is he talking about? Don't worry, you wouldn't be the first person to ask that. But aside from that, usually by the end, things start to work out, and you start to understand. I'm just trying to slowly clean this up because I'm just a psychopath, I guess. You start to sort of understand how to sort of troubleshoot things if something doesn't work your way too. Oftentimes you'll find that you need to flatten or graft something back into a data tree or out of a data tree in order to make things sort of line up nicely. Yeah, anyway, there. So that's a nice little elegant way. All right, so screw that. I told you I would just build it from scratch. Let's do that. All right, here we go. I have a surface in Rhino. I want to bring it into Grasshopper so I can use it and build off of it parametrically. Need to reference it in. Anybody want to remind me what to do? Where do I need to go? Point me in the right direction here. I have a piece of Rhino, a piece of geometry in Rhino. I need to bring it into Grasshopper. So how do I do that?
Curve in Rhino and then set the curve.
Well, this is a surface, but I think you're on the right track, right? So when you go to the params tab, the parameters tab, go to the geometry placeholder set, right? So as Maria mentioned, I think it was Maria, right? You know, I could do a curve, right? And say set one curve or set multiple curves. Same thing with surfaces or meshes or box or B-reps or lines or rectangles, right? So in this case, I have a surface. I'm gonna right click and say set one surface. That closes Grasshopper temporarily. Lets me select the surface in Rhino. And now I have that referenced into my Grasshopper graph. In fact, I'm gonna turn that layer off so I can just see the Grasshopper info at the moment. There we go. That helps me sort of understand things a little better. All right, now I have a surface, I need to get a curve from a surface. In other words, I need to pull the isoparametric curves from the surface. So I'm gonna go to Spline in the Curves tab, right? All the different ways I can create curves and do other things with curves, right? But if I go to Spline, there's a number of different ways I can generate some curves from surface, right? I can get a set of geodesic curves along the surface, but the isoparametric curves is what I want to look for, okay? So for its ingredients, of course, is the surface. That makes sense, right? Think of a globe and then think about, you know, sort of defining which latitude and longitude curves you want from it, right? So we'll plug in that surface. And again, as always, I'm going to right click on where that surface input is. I'm going to say Re-Parameterize, right? What that does, again, you think about this for just a moment. Right? Let's try to pull up my annotate tools here. We have, let's say, U, V, 0, 0 here, right? And then we have a point this way, and then back over here, you can see it, it's sort of x-rayed a point over here, right? So as we move in, let's say U, and we move in the V direction, right? Those coordinates get larger. I have no guarantee. This could be like 23 and 9 or something like that. I have no guarantee of what those things are. When I reparameterize that, what it does is it sets these minimums and maximums to 1 and 1, right? So 0 to 1, 0 to 1. So this then over here, this point would be 0 and 1. This one would be 1 and 0, right? So if we're plugging in U and V parameters, right, we can really precisely start to locate points along that surface, right? As we talked about in those videos that you watched over the weekend. So make sure you hit those up if you're confused or you didn't do it over the weekend. Shame on you. You need to do it, or you're going to be lost. All right. I know you guys probably did it, so I'm not worried, but just in case. All right. So what we need is a UV coordinate, and like I said before, you know, we could plug in any UV coordinate, right? It's going to find the location of this UV coordinate on the surface, right? So we can go all the way to one edge or the other edge, right? Look at that. Or anywhere in between. And at that location, it's going to draw the U and the V iso curves for us, right? All right. So again, we want to generate a set of those. All right. And so I'm going to generate a list of numbers as a U, set of U's, and a list of numbers for a set of V coordinates, okay? Unfortunately, there's no easy way to do this. You got to make a list of numbers. And so that's what I'm going to do. I'm going to go to sets. I'm going to go to sequence, and I'm going to make a range. Okay. Sets, sequence, range. Again, way back in like week 1 or 2, if you need to look at this, we made a grid of points based off of a set of numbers that we plugged in for X and Y coordinates, and even Z coordinates, actually. And so we use series and range as ways to generate a list of numbers, right? So that's where this is coming from. It's not something you've seen before. It's not something you haven't seen before, even if we haven't used it that much yet, okay, or since. Number of steps, right? So by default, the domain of the default domain is 0 to 1, right? The range. And then how it generates numbers is it says, okay, I'm going to divide 0 to 1 in 10 steps. And so what happens is we get 11 numbers out. So 0, 0.1, 0.2, 0.3, 0.4, and 0.1 increments all the way to 10, or all the way to 1, sorry. Okay. The number of steps or divisions, you know, I can make that a parameter. And integer. It's a division operation. So I'm going to set the minimum to 1. I'm not going to leave that at 0. And for the maximum, I'll make something large like 40. Okay. So we can make that a variable that we can adjust. Right. Now look at what it does. Right. Just look at the numbers it gives us out. Right? It's fairly predictable, right? So if we only divide it 1 time, we get 0 and 1, right? There's only 1 division in there. If we get 2 divisions, not a big surprise, right? Going from 0 to 1, divided into 2, we get 0.5 and 1, right? 3 divisions, 4 divisions. 3 divisions is interesting. We get 0.3 repeating, 0.66666 repeating. 4, so in other words, I can begin to generate more or less, more or fewer ribs, iso curves in the U direction or the V direction. And since I wanted those independent from each other, I'm going to go ahead and copy and paste. Now I can have a U and a V. All right. Now, in order to plug these in, right, if I just plug these in like this and like this, it doesn't work, right? So what it does is it just says, oh, you're just giving me a bunch of values, but they aren't like ordered in a way that this is the U and then there's a comma and then this is the V. And it wants that, annoyingly. Just going to turn the sound off on my phone. I don't know why that's on. So let me go ahead and just disconnect those. Okay. But we just need a way to sort of really quickly and easily combine the U's and the V's into one sort of coordinate. And the easiest way I figured out to do that is to go to the vector tab and go to make a point from X, Y, and Z. And I'm just going to plug these in for X and Y. I'll go ahead and turn the preview off for those points. But essentially, the way it gives us points is it gives us the X, Y, and Z coordinates. So now I can just plug those in and I'll interpret those X's and Y's as U's and V's. It's weird. But now you know. Yeah, kind of weird. They really do need to just sort of make them, I'm surprised they haven't, but a U and a V sort of, something better than, cleaner than just using an XYZ point widget, but it is what it is. All right, and so as you can see, I can, highlighting in green are my ISO curves, and I can change the spacing and number, quantity of them with these slide bars. All right. Okay. Now, the other thing I think is really handy is I need to, give these things thickness to become structural ribs, right? And like a sort of depth to them. And so that's what I'm going to do next. The easiest way I found to do this, like I mentioned before, is just to go ahead and offset the surface outwards or inwards. It's up to you. And then basically find the same ISO curves for U and V for that surface as well. And yeah, so let's see here. That's what I'm going to do. I'm going to go to the surface tools, surface tab. And I'm going to say down here in utilities, let's see, offset surface. Right? Of course, if I can't remember where that is, I can just sort of type in offset. You see offset curve, offset surface, right? All right. And it's going to ask for the surface to offset, and then the distance to offset, and then whether you want to keep it retrimmed or whatever. I'm not going to worry about that. I'll leave that as default. Go ahead and plug this in. And then for a distance, I need to give it a value. I'll go ahead and make a number slider for that as well. Whoop. All right. Go ahead and now you can see. In this case, I'm offsetting down. If I want to change that, I could A, go into Rhino and change the direction of this surface, or B, I can just go to this slide bar and I can adjust its minimum maximum. So maybe the minimum needs to be -1 instead of 0. And now I can adjust in this direction as well and offset it upwards, right? So you have that option, right? I'll just do that. Why not? And basically we need to plug plug this surface into this widget as well to make ISO curves here. So I'm going to copy and paste this. I'm going to drag it over here. Really, I wanted to divide the same number of times as the original surface. I'm going to leave all of these original sliders, this range, all these UV parameters I generated, all of those just the way they are, plugged in. I'm just going to change the input for surface to now this offset version, right? And so that way it'll give me the same number of ISO curves for the original surface and with the offset surface, right? All right. Okay. Now, just for the moment, for the sake of showing you, and not something you have to do, I'm just going to go ahead and bake these into Rhino really quickly, just so you can see where we're going here. I'll bake these on layer 3, why not? Okay, like it makes a difference, really. Just going to turn this off for a moment. Just going to blow up my perspective. And so you can see what we have, right? We have a surface and a surface. We need a skin in between those with a curve and a curve. We need a skin in between each of these with a surface, right? And so if I just go to my original native modeling tools in Rhino, right? There's several different ways we can do this. We could loft between these two things, right? So let's, where's loft? There it is. Loft. You could say, do this one and this one, right? Yeah, and it'll loft for me. There's an even easier way than that. You know, the surface from 2, 3, or 4 edge curves is a really nice tool. I'll just go ahead and do that, right? And so, in fact, I think that's the tool I'm going to use in Grasshopper. All right. And so, we've used the exact same parameters and widgets to populate this original surface with U and V curves, and this offset version of it, the surface, with the same U V curves, just slightly offset, right? And so all of these are ordered in a data tree. And so in a nice sort of one-to-one way, we can plug these in and create surfaces from them. So my preference, I'm just going to go to the Surface tab, Freeform, and say Edge Surface. It's the same sort of tool as we were using in Rhino, from surface from 2, 3, or 4 edge curves. I'm just going to plug in the U's for A and the U's here for B, right? And voila. And so everything's in the same order. So I have 13 curves here, 13 curves here. You make 13 surfaces out, right? And I'll just do it again. I'll go pull this down. I'll do the same thing with the V's. There's the V's for that surface and that surface. All right, now we can change their depth, right? And we can change their spacing, make it more dense. Got to be careful with this. First time you actually build this out of Chipboard, you'll regret the day that you decided to do 30 by 30 or something like that, which is decent number of components, that's for sure. All right. Yeah. I baked these in. I'm just going to select these and delete those. They're just annoying, right? Yeah. Now, one thing you'll notice, right, is that these ISO curves are slightly curved, right? Make no mistake, they are. Okay. And so, in Grasshopper, I don't think there is an unroll tool that they've added. Okay. Now I do have an unroll here, and that's from a separate plugin called Lunchbox Tools. And we'll talk about that when it comes to componentry. Right. So that's just building off of the things that you did over the weekend in Grasshopper and showing you how you would approach the task of making these ribs in Grasshopper, right? Now, once I make these ribs and I'm going to populate each of these grid cells with the components, it becomes really important that I remember how many times I divided the surface in U and in V, right? Because I'll need checkers in the same number of checkers and size checkers in the U and the V direction as well, right? So with that in mind, right, I would try this in Grasshopper and then save that file, okay? And then I'm going to show you now the script that you can run to generate the rib system, the two-way rib system. So again, the idea here is that there's multiple ways to do this, okay? But when it comes to making the ribs, these ribs that we just made in Grasshopper, it's kind of a red herring here. I'm actually going to advise you to use the the Rhino script that I show you here in just a second, okay? But I wanted to show you this in Grasshopper because A, it's possible to do, although it becomes a little more difficult to do all the vector calculations in order to find all the intersections and unroll everything out and then add the sort of notches and things like that for sliding these things together. So, but I did want you to see this because in Grasshopper, you'll be working with the surface in order to make the componentry that sits on top for the shading devices and then testing that stuff for shading performance, right? So I just wanted to show you this, and I want you to follow along and try it because, again, there's more than one way to do this. But now let's look at the shortcut way that I'm going to give you, okay? All right, so here, back to my surface, right? And I'll just point this out on canvas. I also say, try to run the Rhino script I've shown in class today using the monkey script editor. And here's the Rhino script file that you can save and download. Okay, I think it takes you to hopefully a Google Drive, right, where you can download this .rvb file. And so I have my surface, and I'm going to go to the Tools pull down in Rhino, Rhino script, edit. Okay. So the nice thing about a lot of these tools, these software, is that you don't have to just use them right outside the right out of the box. You know, I say this, it's a lot easier to do this in Rhino, but you can still do it in Revit and these sorts of other tools. There's a number of different ways you can write your own scripts and program. You can develop your own programs for it or plugins for it. And so Grasshopper is a way to sort of do the scripting without actually learning a scripting program. It's called visual scripting, right? Where we're basically programming an algorithm without actually typing any script, right? So it's the same logic. But you can also actually, if you know C# or VB script or Python, you can actually write your own end user scripts in Rhino actually quite easy. And so if you go to the tools pull down, Rhino script, edit. I've had my cursor over this so you can make a note of it. I've also noted where this is at in the Canvas instructions, right? It'll pull up this script editor, and you can open that RVB file that I give you, right? Surface to grid shell, right? And you'll see a bunch of text, and I can't remember how many lines there are in this. Not a huge thing, 298 lines code, right? This was originally developed by a buddy of mine quite a while ago. He doesn't care if we use it, for educational purposes. And I've actually, since Rhino, this is like several different versions of Rhino ago, so I've got to sort of fix some things in this as we go along. And so you'll see some green stuff where I had to label some changes and fixes and things like that. But essentially, all you have to do, you don't have to write code. You don't have to write any script. But you see this green triangle where it says run script? I can click that, and then the script editor disappears. And you just look at the command line in Rhino, and it's going to ask you, just like if we were running a script here, it's going to ask you a command here. It's going to ask you for certain things. So it's going to say select the surface to populate with tiles. I'll go ahead and select that surface. The number of tiles in the U direction, so I'll say 20. And then in the V direction, I'll say 20. Into the height of the strip, I'll say 0.25, like 0.25 inches. This is the distance between the strips when they're unrolled and laid out on the XY plane. So I'm just going to pick something large for these right now, 20 and 20. Then enter a material thickness. In this case, I'll say 0.060, right? In inches, that would be roughly the nominal size, at least, of your chipboard. And I'll hit enter, and now it's going to generate all this stuff for me, right? Just like Grasshopper does in real time. This one does it. It asks me for the ingredients and the parameters up front, and then it does all of these things for me, right? Which is kind of satisfying as well. And so you can see it took this and it generated the three-dimensional set of ribs, 20 by 20. Then it also laid them all out for me on the XY plane. Not only that, but it gave me like these green scoring lines. So you can actually have the laser cutter score that zigzag to make it a little more flexible if you need to. It also, based off the material thickness I gave it, added these notches, right? That can be laser cut out so that these things can, like the U's and the V's can slide together like this and notch perfectly. And then it also labeled each one, like V0, V1, V2, all the way to V20, and then U1, U0, U1, U2, U3. And then it put them all in different layers, right? So cut layer versus score layer, right? So, because that's an important thing when it comes to laser cutting, right? So when it comes to actually generating the ribs for laser cutting, I actually encourage you to look at this script and run it a couple of times until you get something that you think you like when it comes to this sort of aesthetic three-dimensionally. And then the output when it comes to flattened out planar components. Like now, all you need to do is sort of move these around and draw the 18 by 32 sort of window or box in your screen and arrange them so that they can be laser cut, taking a laser cutter and laser cut. And we'll talk more about that on Thursday or on Wednesday. Sorry, not Thursday, Wednesday, when Kyle's here, right? But this script is really handy way of just sort of breaking these things down and doing that Grasshopper stuff. But it's all taken care of when it comes to you know, generating the labels and the notches and everything else, right? You don't like the those scores and things like that, just turn those off, right? Although again, you want to make sure that you keep the labels, right? Or you add the labels yourself. And again, when it comes to the mono, maybe I'll look and see if I can find a mono type font for you guys to use for that, so that you don't have like outlines, like double the outlines for the thickness of the characters here, but you just have like a V, like 2 lines, you know, and a circle for the 0, because that cuts down on the amount of laser cutting that's required. And you know, you wouldn't think that adds up, but it does add up over time. It saves you time and therefore money. Okay, so I'll look for a mono stroke font that you guys can load in your system and then use for this script. And if I need to issue an addendum to the script, I'll let you know. In order to, I think by default right now it's just picking Arial or whatever the default font on your system is. And I'm not sure why, but it's also doing some crazy things to the V here. But that would just be something that you just lightly inscribe, you know, lightly engrave, you know, score basically into the material, as opposed to through cuts for the overall shape and then the notches. Those would be through cuts. Interestingly, these notches are just separate boxes. Did you guys notice that? Yeah. And so, you know, what I would do is I would actually cut those first. That way, in case you don't want to do the through cuts and then accidentally one of those pieces shift and then the notches, before the notches get cut through them. You know what I mean? Because the laser cutter sometimes, you know, it has it's drawing air through. You know, it's spitting wind out of the cone on the air assist. And so, you know, the idea is that you probably want to sequence this so that you do the engraving first, the light scoring, then you do the notching, and then you do the overall through cut. However, you know, there are shortcuts to that. Like, let's say I'll just show you this real quick. I'm not sure why why that isn't grouped together. I'll just turn off the scores real quick. Okay. So for instance, there is a curve Boolean tool. I don't know if you guys have ever looked at this curve Boolean. What you can do is you could say delete input, combine regions, yes, right? So I could say, there we go. Oh, sorry, hold on. Curve Boolean, delete input, all. Select the curves, then select this region to keep, right? And then it trims it all out for you. Right. But anyway, what? Damn it, what's going on here? Right, here we go. And then, oh, sorry, that's on a white layer now. For some reason, I don't know why it's set to, oh, sorry, it's because it's, yeah. I was like, why did it disappear? Because I'm an idiot. There we go. Right. So that trims things up pretty quickly, if you wanted. But there's nothing wrong with just sort of going through and cutting all these boxes. It's about the same, actually. Okay. And again, this spacing 20 and 20 is just parameters. You can, you know, when it asked me for those parameters before, that's what I did. So let me just undo. I'll do that one more time for you. There we go. I'll do, was I doing this file before? I'll do this file, maybe, this surface. I didn't do that before, let's see. So let's see, I'll just hit the green arrow, the green triangle. Number of tiles in the U direction, I'll go with 15 this time, and 15 in the V. 0.25, X distance between strips, I'll go with 15 instead of 20. I don't know why, I don't care. Intermaterial thickness 0.060. That's really important that you get that. Right. All right. And once again, you know, did it for this one. Added the ribs. 15 divisions, so probably 16 and 16. Right. It gives me all of the flattened information ready to be laser cut in the XY plane. Right. So I just need to sort of select all of these and try to get them, nest them together for a more efficient sort of laser cutting session, right? Where I try to maximize the yield in my piece of chipboard, minimize the travel time for the laser, which also, affects time and money, time and cost, and on and on and on. Okay. Make sure you keep these labels. These labels are really important. Okay. Because you want to make sure each of these are going to a specific location. They're all different. So if you don't remember which one's which, then you find yourself in just a seriously avoidable, really complex jigsaw puzzle. You don't want that. Trust me. I wouldn't wish that on my worst enemy. All right. All right. So I've talked a lot. I've shown a lot. What questions do you guys have? Feel free to shout at me. No questions. Awesome. How many of you are like jumped up in your seat and like the hair on the back of your head started standing up, right? Like when you saw this Rhino script. Am I crazy? Like there's something about that. The first time you see it and you're like, oh my goodness, it's like pure computational nirvana. Maybe I'm, overreacting a little bit, whatever. But so I found that putting a 0 in the notepad in Grasshopper makes a widget go red. Yeah, it depends on what kind of input you're doing, right? So for instance, if it doesn't want a 0, it'll let you know. For the model part, yeah, making, right? Ooh, yeah. Get to go back to the School of Architecture and make sure the building hasn't burned down. Hopefully it hasn't. That'd be
Hey Josh,
tragic.
when loading in a script, do you always have to open the edit Python scripts?
Yeah, that's what you want to do. Now, you probably want to use Rhino script if you want to. But yeah, you see it, and then you can basically run it. That's the easiest way.
Oh, okay. There's like no shortcut to rerunning the script that you already did?
Well, usually after you're done running it, it comes right back up with the editor, so you can just hit green again.
Oh, okay, okay.
Yeah.
Thanks.
Yeah, this is the Rhino. This is the built-in Rhino script editor. They used to call it Monkey script editor because, of course. Python's nice if you guys know any coding. Python's a really nice language. You can do things with C# in Rhino and Grasshopper. And of course, originally the Rhino script methods were built on VB script. So you have a harder time on the Mac side of things. I don't know if you can really run VB script. I think that's built on the .NET framework. So I think it's a Windows thing. However, Python, again, you can easily run Iron Python library on the Mac side if you're running a Mac. If you're having any problems with running these, if you're on the Mac side of things, let me know, and we can just try to, we'll just have you tag team with somebody on a PC and just to generate that or something. But to me, it's, again, just sort of whetting your appetite for getting under the hood with this stuff, right? There's a lot of numbers and things like that, and that stuff can actually be designed too. And in fact, some of the firms that I used to work at, and a lot of good firms now, even have teams of people who just deal with this stuff on a full-time basis, like sort of extending these tools for design teams, SOM and HOK and KPF and BBJ and those sorts of firms, the big global ones. Foster and Partners, I have a couple buddies that used to work for them. Geary Technologies for Frank Geary and Associates. And on and on and on. So there's a I guess I could say, there's an entry level sort of like, use the software out of the box. But what we're interested in is sort of thinking about, just like we would, interrogate, let's say, a pencil and pen, to create things like the perspective drawing and isometrics and things like that back in the Renaissance. Now I think as the time is ripe to sort of again, interrogate our new digital counterpart tools, and to make them work for us instead of the other way around. Sometimes it seems like design is driven by what the software allows you to do rather than making the software do what you need it to do, right? So this is very much a part of it. But the other thing is, get used to sort of knowing or being able to at least have an intelligent conversation with somebody who can code, right? What you guys are learning in Grasshopper is basically coding without learning the syntax, right? So, but it's the same logic, right? You have inputs, you have a function, you have outputs, right? And then it's all about how do you get from point A at the beginning to point B at the end. So how do you get from the ingredients to the output you want at the end? Defining the parameters, defining the variables. We do all of that as well. So anyway, I hope that's helpful. And what I want you to do between now and Wednesday is play, break things, figure it out, right? And come Wednesday loaded with questions on why this went wrong, or a question like Christian had where I put 0 in and then everything broke on me. All the widgets turned to red. Sometimes really interesting things happen when the widgets turn to orange or red, but oftentimes it's just we're giving it something it doesn't want. So for instance, if you it'll just tell you, instead of what happens, like let's say you're dividing something by 0. So what Grasshopper could do if it didn't have the debugging control is just throw itself into a never-ending loop until you had to restart your computer. Fortunately, it doesn't do that. It says, oh crap, you're trying to divide by 0 and we're not going to let you do that. I'm going to turn the widget to red and give you a warning message instead. And I'm not even going to try to go down that computational rabbit hole, of trying to divide something by 0, which doesn't work, right? So does that maybe illuminate a little bit, Christian? I was fine, your demonstration didn't act like yours. Hi, Josh, how much chipboard do we need? Probably 2 sheets, okay? Probably 2 sheets. Probably 2 sheets per draft, right? So you can make 2 drafts. So I would start with 2 sheets, and if you need to get 2 more for the final, right, then that's perfectly fine, but you have some time, right? This isn't going to be due until a month from now, the final project 2 model, okay? We'll 0.03 chipboard work. What did we talk about before? Honestly, I think the thinner you go, the better, within reason. Like you can try it, right? Absolutely try it. But then with the thinness, you're having to deal with, right? So for instance, if the material gets super duper thin, almost paper thin, then what happens is you might need to adjust the depth of them, right? In order so they don't get so weak that they just tear, as well as understanding the spacing and density of them, okay? So the point of this is that, we're doing stuff digitally, and everything works really well when we can just sort of, in the ether and the virtual environment, where things are accurate to much more extreme tolerance, like, decimal points of accuracy, right? And then we try to build something out of wood or chipboard or plexiglass or something like that. Even with a laser cutter, these things, they absorb moisture, they expand, they shrink, they curl. They're not perfect. They're perfect within a tolerance, but that tolerance is much larger than, let's say, the digital tolerance in the virtual environments that we deal with. And so, I think part of this is that you have to negotiate these things, and that's why we're doing it once before we actually do the final version, because you're going to learn a lot. You're going to push the material, and the material is going to push back. And sometimes the material fails. Sometimes the material just says, to you, and doesn't let you do what you wanted to do. And so, you'll have to dial in those tolerances after doing it once. In fact, that was the biggest thing last year, right? That feedback loop. You do it only to understand how you need to adjust the variables here to do it really well. And those are highly dependent on the materials and the tools that you're using, right? So we're, again, closing that feedback loop between not only just designing stuff, but then starting to understand the implications downstream. Like, how do you make it? How does that begin to inform the decisions you make at the design level, right? And that's another nice thing about the parametric design tools that we're using, is that we create those variables. We don't have to actually remodel everything. We just start to adjust sliders or adjust values, and all of the changes propagate through from left to right. Okay, so are the sheets 1/18th? I think they're usually like 16th, or look, I would say 16th inch chipboard. Now that's probably a nominal size. You know how we have 2x4s, right? You know how the dimensions of an actual 2x4 aren't actually 2 inches by 4 inches. That's a nominal size, not an actual size. They're actually like, you know, yeah. So like they're 3.5 by 2 and 7, or 1 and 7, 1.75 or something like that, right? And so the nominal, like get 16th inch or 1 ply, I think that's usually like 0.06, 16th inch would be 0.0625, but I think really the actual is closer to like 0.060, right? 1.5 by 3.5. What is that? 2 by 4. Yeah, 1.5 by 3.5, not 1.75 by 3.5. 1.5 by 3.5. Yeah. Which is really important when you're framing a wall and you're like measuring everything out and putting all the X's on the bottom, the ground plate. Yeah, you don't want to be off by 1/4 of an inch, because by the end of the wall, you're off by a lot. So anyway, let's see. What else? What other questions you guys have? We're going to talk about laser cutting for realsies on Wednesday, because Kyle will be here and we'll talk about these things. And then the idea is that you have a weekend to sort of start preparing this rib system for real, like get it all ready to laser cut, so that on Monday, you know, we can, you know, say like start making, signing up for appointments and laser cutting over the weekend, the next week and a half. And while you guys are preparing that stuff and just, you know, taking it at your appointed time at the laser cutter, then in class we'll be talking about going further, like doing the componentry on top, and then how we can measure its performance and things like that. Okay. And then eventually we'll turn a corner and we'll just start talking about doing the instruction diagrams and making this beautiful exploded axon. Instead of having in Canvas, there's an example of the drawings, and there's a lot of different things composed on a really long sort of horizontal board. What I'm actually thinking is that this time around, maybe we just make one really super awesome exploded axon that's vertical. It'll be so sweet. With the catalog of pieces running alongside of it and sort of showing how all these things explode, you know, upwards and back. So I have some ideas on that for the drawing part. Just, you know, maybe it's quality over quantity. So we just make one beautiful, gorgeous, elaborate exploded axon, rather than trying to do an exploded axon and this and that and the other, right? I want to give you maybe some more direction for that final deliverable for the drawing part. So that's where we're going anyway. All right. So between now and Wednesday, play, structured play. Play around, break things, right? Try your best. Watch this video that I upload from today, because this shows you exactly what I did in Grasshopper. It shows you exactly what I did in Rhino script. And play around, right? See what happens. And, you know, again, by the end of this class, some of you know a lot more about this stuff than I do, which is kind of an interesting thing, right? You get as much in as you get as much out as you put in. So, but for even those who aren't fully 100% invested in this course, you get a lot out of it. So, last year I sort of changed a lot of things, and you know, I felt like I was doing a pretty decent job anyway. But man, they just loved it last year. I don't know, each cohort's different, so but this was their favorite, and I thought, you know, it could go really sideways really quickly. I tried to put just enough parameters to the problem to keep people on track, so they wouldn't have disastrous results. And you know, the first result, don't be discouraged, I'd say, if the first draft of your model turns out like hideous, because it will in a lot of cases, right? You'll have to make a lot of assumptions, and then you'll have to build it, and then you'll realize a lot of the assumptions you couldn't possibly have understood until you actually make it once. Okay, and that's part of this. That's part of the learning experience. Okay, so anyway, I'll see you on Wednesday, and good job, and just keep going. Yeah. By beginning of November, the remote learning has taken the life out of most classes. Yeah, sorry about that. Not much I can do. Vote November. That's what I'll say. You can take that however you want. I don't care. But you young people absolutely should be voting. All right. You have the most at stake. Trust me, we're rooting for you guys because we're leaving you a lot of problems. All righty. I'll see you Wednesday then. Take care. I'm going to leave because that way I can get the video. I need to get the video up for you guys. So, all right. Take care. See everyone Wednesday.